Welcome to the first video for the micro-credential course, Techniques of Integration. In this module number 1, we are going to deal with a few integration examples. So the first example we are going to see is an example of integration comprised of an function that looks like what you see on the screen. The function comprised of an numerator function and a denominator function. So basically, the integrand function is an algebraic function. In many cases, when you are dealing with the integrations of function that made up of a numerator and the denominator, or other function that contains only a numerator function with no denominator function, the first method that comes into your mind should be the substitution method. It is the most simple method that you should try in the first instance if you have no any other better idea of how to perform the integration. The correct applications of substitution lies on the choice of the right substitutions that is usually taken or picked from the expression of the integrand function. Before we proceed on choosing the right substitution, it is very important to realize the relationship between the numerator function and the denominator function. It is quite straightforward to see that the numerator function is an derivative of the argument inside the square root of the denominator function. So you want to make a choice of substitution such that when you take the derivative of the argument in the square root of the denominator function, it will return you the expression of the numerator function. When that is done, then you'll be able to translate this integration into the form of du over u. Let's try out the substitution method to solve this integral problem. The obvious choice for the substitution is to use u to replace the quadratic expression. When you take the differential of du, which is by definition the product of du dx times dx, it will then give you du dx, which could be derived from this expression, that is 2x minus 9. 2x minus 9 is just the expression of du dx. So we have this term done, then we just fill up the dx. So it is very obvious that the product of the numerator function and dx is simply du. And the denominator function is simply the square root of u. Integration of 1 over square root of u, if you write it in this form, you'll be able to perform the integration of u raised to the power of minus half as u to the power of half times 2 plus an arbitrary constant. And remember the substitution rule, u is just the expression of the argument inside square root of the denominator function. U to the square root raised to the power of half is then simply 2x minus 9x plus 1 plus an constant. That is how we use the substitution method to solve the integral of example 1. As a conclusion to this video, we have shown you how to perform the integration of this algebraic function, which is made up of a numerator function and a denominator function. We pick the right substitutions of u equals to x squared minus 9x plus 1, which happens to be the expressions in the square root of the denominator function. And we also recognize that the numerator function is related to the quadratic term in the denominator function via the differential relationship. Once you define the substitution u in terms of x squared minus 9x plus 1, then du will be just the expression of the denominator function. The identification of the substitution rule is most crucial. Once you have this expression written down, then the integrations with respect to x can then be translated into integration with respect to u. And the integrations in terms of u could then be easily obtained to be just 2 times u raised to the power of half. You just substitute u with the quadratic expression in terms of x, then you get the answer for this integral.